In this class, we're going to consider quadratic expressions. And a quadratic expression is a special type of algebraic expression. It's got a particular form, and these are super important. These are going to appear in a whole bunch of math techniques you're going to learn in the future. So just learning some of the key ideas about them now, which is the goal of this class, is going to make working with these in the future a bit easier. So in particular, these are important because they feature in quadratic equations, which is the technique you'll learn in the future as well. And getting some of the ideas about the form of a quadratic equation down by learning this stuff will just, again, make those easier to work with and to solve when you get to those. So what is a quadratic expression? Well, the first thing is that the key feature of a quadratic expression is the presence of an x squared term, but there can't be a higher power of x. There should be no number greater than 2 in the exponent of any of the x terms in your expression. Well, the expression doesn't have to be in terms of x. It can be some other variable. It could be another letter, but usually going to be x. We're going to use x here. So if you've got an x squared in your expression, but there's no higher power of x, then it is a quadratic expression. If you've got anything else like an x cubed or an x to the power of 4, then it's some other type of expression like a cubic or a quartic or some kind of polynomial. These are different types that have got higher power. So this is what you're looking for, the presence of an x squared term. You can have other terms as well, and indeed the general form, let me put it here, the general form for a quadratic expression is some coefficient a multiplying to the x squared term plus some coefficient b multiplying to x plus c, like this. So this is the general form that you should learn for a quadratic expression. The a, b, and c values can almost be anything, but there are some restrictions. So the a value certainly cannot be 0, because if the a was 0, then that would wipe out the x squared term. And if we lose our x squared term, we've no longer got a quadratic expression. But the a can be any other number. It can be positive, it can be negative, it can be a whole number, it can be a fraction, it can be a decimal. Usually you'll see them as positive whole numbers, or certainly whole numbers, but usually positive whole numbers. The b and the c values, they can be anything. Okay, so it's okay for the b can be 0. It doesn't have to be 0, but the b can be 0, and the c value can be 0 as well. Again, they can be anything. They're variables. They can be variable. The x is the variable, but b and c can be variables. You can choose to make them, you'll see them being different numbers, but they can be 0. It would be okay if you lost your b and c terms. If the b and c terms were 0 and they basically disappeared and you were just left with your x squared term, that is still good enough to be a quadratic expression. In fact, the most basic quadratic expression we can get is just 1x squared. And then when we start adding in b values or c values, we get other terms. It's also okay to lose, for example, the b, make the b 0, so that you've got an x squared term, but still got a c value, and the other way around is fine as well. So all these different forms, but the key thing is to retain that x squared term. When the b and the c values do take on certain numbers, that gives rise to particular forms of the quadratic expression, and each of those forms has got a particular name, and the name is really important for some of the work you're going to do later. So let's just take a look at an example of those different types. So if you've got all three terms, that's called a trinomial. So tri, means 3, so a trinomial. A nomial is a reference to the powers, a power of 2, an exponent of 2. This is an exponent of 1. You can imagine there being an x to the power of 0 here, because anything to the power of 0 is 1. So trinomial just means 3 powers, 3 different powers, which is exactly what we've got here. In the case of a trinomial type of quadratic expression, you've got to retain all 3 powers. So an example would be something like, say, 2x squared plus 8x minus 12, something like that. We've retained all 3 terms. That's a trinomial type of quadratic expression. A second type is a binomial, which I'm sure you can figure out. That's pretty similar. It just means you're losing one of the terms, but the term you're losing specifically in the binomial is the constant term. So you could have something like, say, 3x squared plus, 7x. This would be an example of a binomial. And then finally, we've got something which is called a difference of squares. Okay, so we've got a difference of squares. Okay, and in a difference of squares literally means something squared minus something squared. Difference, remember, means minus mathematically. So in this scenario, you've got something squared, like an x squared, minus something squared, like say 4 squared. And that's called a difference of squares. Usually if it was written as x squared, if it was a difference of squares, it would usually be written as x squared minus 16. So it's not explicitly shown as being something squared, but the number 16 is 4 squared. So that's a difference of squares. I should really go back to the binomial actually and say that I think I misspoke. So this could be something like 3x squared minus 12, something like that. So that is not a difference of squares. It's not a trinomial, so it fits into this category here. The important thing with these different forms, at the moment for you, it's just learning the words like difference of squares or a binomial or a trinomial. The important thing later on is how these factorize, okay? And factorizing is going to be one of the key operations you're going to perform with quadratic expressions, particularly when you're using them to solve quadratic equations, which you'll do in the future. Often that causes confusion, but sometimes it comes down to not knowing the terminology well enough. If you know that there are these 3 types, and sometimes if you can find the type which goes with a particular factorization, which is a little bit in the future, but if you can find the type based on a process of elimination with the other types, because you really understand and know all 3, that can be really helpful. So it might seem quite trivial at the moment to learn the word that goes with the form, but you'll see that later on in the future, if you do know these really well, it can make your life a lot easier. Or to put it another way, if you don't know them, it can make your life a lot more difficult. So just going back to the basics here, this is a general form of a quadratic expression. You should learn that. Different a, b, and c values give rise to different specific forms, and these specific forms have got different names, which are going to become more important in the future. Try and learn those names now, try and learn the form, maybe make up some of your own examples, and it will just help you when you start using these to be able to use the correct words in your head and just work with them a lot more easily than if you're just seeing it as all one big sort of mess of algebra. If you can categorize them into these different types, rather than just saying, oh, it's a quadratic expression, although you should know that as well, then that just makes it a little bit more specific and easier to work with. So I hope that makes sense. That's basically an introduction to quadratic expressions.